Practice problem D. It's a probability question about an urn. And so we could use the probability tree approach or the sample space approach. We'll use the probability tree approach in this video, and in another video we'll use the sample space approach. So we've got an urn that has 7 marbles in it. 4 of them are purple, which I use an L for, and 3 of them are pink, which I use a K for. We draw twice from the urn, and there's 2 separate parts to the question. We either replace after we draw, or we don't replace after we draw. And the question is, what is the probability of drawing an L on the first and an L on the second? In other words, drawing a purple on the first draw, purple on the second draw. What's that probability? So we're going to do probability tree approach. We'll do question 1 first. That's with replacement. So one way of looking at this is on the first draw, we could either draw a purple or we could draw a pink. What's the chance of drawing a purple on the first draw? Well, there's 4 purples and there's 7 possible draws, so 4 over 7. And what's the chance of drawing a pink on the first draw? Well, it doesn't matter because we're not going to go down this path on the tree, because we know our first draw is a purple, so this is the only pathway that we really care about. So we've drawn a purple on the first draw with probability 4/7. Now what could happen? Well, we've replaced the purple that we drew, and there's two more possible options here. For the second draw, we could either draw a purple or a pink. Well, we know we're interested in drawing a purple, so let's work out that one first. So we've drawn a purple, and now on our second draw, what's the chance of drawing a purple? There's still 4 purples, and there's still 7 marbles because we replaced the purple that we drew on the first draw. So the probability of drawing a purple on the second draw, given that we drew a purple on the first draw, is 4/7. And that's going to land us at the event, drew a purple on the first, purple on the second, which is the event we're interested in. Which means we don't even have to explore any of these other branches. So what's the probability of drawing a purple on the first and a purple on the second? It's going to be the product of the probabilities here. So 4 times 4, 16, divide 7 times 7, that's 49. And okay, that's good and dandy and all, but it would be nice to have a better idea of what the chances are. Like, is it more than 50%, less than 50%? So we'll do a division here. 16 divide 49 is 32.6% or thereabouts. So about a 1/3 chance of drawing a purple on the first and then a purple on the second, given that we use replacement. All right, let's do no replacement. So again, there's two, this is one way of seeing it. There's 2 pathways after the first draw. Either the first draw was a purple or the first draw was a pink. So, well, we know we're going to be looking for the event where the first draw was a purple, so we're going to pursue this path. What's the chance we went down that path? Well, there's 4 purples, 7 in total, so there's a 4/7 probability that we went down this path. And that lands us here, where the first draw was a purple. So now think about what's left in the urn. There was 4 purples and 3 pinks. We took one of the purples out, so now there's 3 purples and 3 pinks. So when we do the second draw, there's still 2 options. We could either draw another purple or we could draw a pink. And now we're interested in drawing a second purple, so we're gonna figure out this branch first. So I'm just thinking here, 3 purples left, 6 marbles in total. So the probability of drawing a purple in the second draw is 3 over 6, which of course can be reduced to 1/2. So let's write it as 3 over 6 for now. Okay, so we know that's the pathway that we're looking to follow here. We drew a purple on the first, purple on the second. And that lands us at the event of interest, where the first draw was a purple and the second draw was a purple. So now we can calculate the probability of that event happening. It's going to be the product of the probabilities on each of the branches that we followed. So 4 over 7 times 3 over 6. 4 times 3, that's 12. Divide 7 times 6, that's 42. And this can be reduced to, well, each of them are divisible by 6. So divide this by 6, we get 2. Divide this by 6, we get 7. So the probability of drawing 2 purples, given that we're not replacing, is 2/7, or, based on calculations, 29% chance. So that's how we would use a probability tree to sort this problem out. And that's it for practice problem D.